welcome back to our channel EduUdr. This is Cindy Nyoumsi and you're about to watch the part 2 of the introduction to SQL. If you haven't watched part 1, make sure to check it out so you can understand what's happening in this video. Also, for more videos like this, make sure to like and subscribe below. On that note, let's get to it. In this part 2 intro, like I mentioned in part 1, we're going to learn to identify characteristics of a table, filter a table, modify and delete data in a table using SQL, and last but not least, explore a few of the long list of things you can do in SQL and discuss other things that are not so possible to do in SQL. Without further ado, let's get right in. So the whole point of identifying characteristics of a table is to figure out whether we trust this data enough to use for analysis. Depending on the type of analysis you're running, there are lots of ways to test whether your data can be trusted. And today I will cover 5 basic characteristics to look for. Number 1 is figuring out what kind of data the table is storing. This means investigating if the data is relevant to the problem you're trying to solve or question you're trying to answer. Does it have all the necessary values you need, or will it require for you to combine it with another table to get a complete data set? And are the records in the table independent of each other? Now, why don't we look at an example to see what I mean here? Let's say I own a pharmacy and I want to know what percentage of my visitors in the last 12 months were here for prescription pickups. So I go into my database and I find a table titled Pharmacy Visitors. Oh, that sounds like a table that will have a data I might need to answer this question. So the first thing I do is to see what kind of data is in this table and if it fits my needs. Taking a closer look at the table, I see it only has information about the visitors, such as their names, address, etc., but not actually what they were there for. This means this table is irrelevant. So moving on. So I find another table titled Pharmacy Visitor Events. I look into it and I see it has different events related to what the visitors came here to do, whether it was for consultation, pickup, or prescription. This is a lot more relevant than the previous table and fits my needs. So yay! But hold on, I'm not done yet. I still need to check if I have records for the last 12 months and if the records are independent of each other before I can dive into querying and get the answer to my question. I'm not going to dive into that because I will have more videos on exactly how to query a table to find if it's complete, but for now, just know these are some of the few things you should definitely verify before using a table for analysis. Continuing with the list, I will also need to verify if the table I found is in a format that can directly answer the questions I have or solve my problem. Or are some values in the table still stored in raw form such that I will need to extract or transform them? For example, sometimes some values in the table can still be in JSON and will need to be extracted. Also, will I need to pivot this table to get the answer to my questions? And then, what are the data types of the columns in the table? Remember when we created a table in the last intro to part 1 video and had to specify the data types of the columns? Well, when looking at an unknown table, it is very important to know what data types each column holds so we can quickly identify if some fields are wrong. So do all the values strictly follow these data types, or are there error values? That is, do we see integer values in a column that should only have characters, and vice versa? Are the values standardized and homogeneous? Say a column holds state names, but some states are abbreviated while others are spelled out. So these are a few things that could really make your analysis faulty and that you should really be able to catch before you start querying your table. And we're not done yet. We still need to know if it's a temporary table, or was it only meant to hold the last 6 months of data and is to be deleted after? Is the data up to date and contains the most recent data by date? Are some fields you might need in the table null? Does this data have duplicate values? And last but not least, it is also helpful to figure out how large a table is. How many rows and columns does it have? Do you need all the fields? Could you afford to limit the results? Will you need to strategically pull from this table to remain efficient despite the size of the table? So yeah, there are quite a few things, but there are a lot of other things to look out for in a table before getting ahead and using it for analysis, because your results are only as correct and true as the data you're using. So these are very, very important steps for a data analyst. Okay, now we're actually going to learn some tools that could be helpful in allowing us to identify characteristics of a table and whether we can trust it. A SQL clause you probably use a lot if you're working with SQL, at least I do, is the where clause. It allows us to set conditions on our data and thus filter what we want or don't want to see. Here is the syntax for using a where clause. It always comes after the from keyword and then your condition. That's it. Very easy, very straightforward. Here's an example with the pharmacy visitor events table from earlier. Say we only wanted to look at all the records for visitors who came to pick up only. we would use the where clause to put a condition on the event column to specify that we only want to see records where the event column has the value pickup. It is literally like speaking English to a database. Here's a list of few more operators you can use to set conditions in your where clause that are very useful. We just saw the equal to operator, but you also have your common, less than, greater than or equal to, and more. I find the like operator very interesting because it lets you set a condition on patterns, which is really cool. And it can get really fancy once you start using regular expressions with this. Now, I know I just mentioned some terminology that you might not be familiar with, but do not worry. If you subscribe, you're going to get alerts for videos where I go in a lot more deeper on using some of these operators and even about regular expressions, which is kind of a mini programming language in itself, and I find it so fascinating and just so unique. So make sure to subscribe so you can see those videos coming soon. Okay, we're finally looking at how to modify data in a table, and to do this we use the update statement. Here's the syntax for the update statement. If you remember a create table statement from our last intro to SQL part 1 video, they're pretty similar. Starts with the keyword update, followed by the table name, then the keyword set, followed by the columns whose values you want to update and the values you want to update them with. And now the most important part, and we just learned this, is the where clause, which is part of the update statement syntax. And it's very important because without the where clause in the update statement, you're going to update every record in your table, which is quite dangerous if that is not what you want to do. So let's use the pharmacy visitors table from earlier and update some data because there is no John Doe. It's actually Jonathan Doe. Haha, okay, it's stupid. I'm trying to make shit up here, so bear with me. So he actually lives on 1 to 6 and not 1 to 3 Street. And to update using the update statement, we get, so update pharmacy visitors, which is our table name, set the first name column to Jonathan, last name Doe, and address 126 Street. And very importantly, since we only want to update John's record, we use his unique visitor ID as a condition in a where clause, and ta-da, that's it. Okay, now let's try updating the event pickup to instead say pickup prescription in the pharmacy visitors events table. So we have update pharmacy visitor events, a table name. We set the event to equal pickup prescription, and we only want to make that change for pickup events, which is why we set a where clause condition on the event column equal to pickup. And this change will happen for all the pickup event records. Now, if we did not have a where clause here specifying which event, we would end up with a table where all the events are now pickup prescription, which would be really bad. So don't forget your where clause. Last but not least, how to delete data in a table. And I'm going to repeat myself here. We are deleting records in a table. Not deleting a table, just the records in the table. The syntax to delete a table doesn't actually use the keyword delete at all. Anywho, let's see how to delete records in a table. Here's the syntax to delete records. Starts with the delete keyword, followed by the from keyword, then the table we want to delete from, and then we have a where clause again with the criteria for the records we want to delete. If we delete Jonathan Doe's record, we simply write delete from pharmacy visitors, where visitor ID equals 1, and here we're only deleting one record, and that's Jonathan Doe's record. And then similarly, we can delete all the pickup prescription records we updated earlier. And although very dangerous, if it isn't your desired outcome, we can also delete all the records from the pharmacy visitor events by simply omitting the where clause, and we'll end up with an empty table. Okay, time to wrap up this intro to SQL part 2 with a list of other things you can do in SQL that we haven't talked about, as well as a few things I'm not going to say that you cannot do in SQL, but actually that are a little bit harder and tougher, and I'm just going to use the simplest thing that is very possible but can be a lot tougher to do in SQL. Anyway, let's start with the list of lots of other things that you can do in SQL. You can basically do, honestly, anything when it comes to talking to databases. Literally anything that you can imagine of, you can do it with SQL. And again, the only thing is some things are going to be harder to implement, especially if they're repetitive things that you would need to do every day that you might, with another programming language, you might kind of, write a function for it that you can just call and do each time, or write a query that works for all kinds of data, but based on the complexity of the data, might not end up working that way. One of the most basic things that can end up being difficult to do in SQL that is otherwise easy with the use of unique identifiers is this concept of joining tables. And this, you might not be familiar with this term yet, but I'm definitely going to have videos about this later that touch on what joins are. These are kind of more advanced SQL concepts, but basically usually you might have two tables and you kind of want to combine them, and sometimes it's easy to combine them if you have unique identifiers that are common to both tables. But sometimes you'll end up encountering two tables that you really need to be combined, but they don't have unique identifiers, and you have to rely on using other fields to sort of combine them so that it makes sense. And this sounds like it would be an easy thing to do, but it actually can end up being quite tough to do in SQL. And I found myself in situations where I would have to leverage using another programming language to be able to combine these data sets or tables. So that's a very basic example of something that we wish would be as easy to do in a relational database model. But because a relational database model relies on this concept of sets and kind of intersection of sets through unique keys that are intersect in both of those sets, but it's not always the case. You kind of have to engineer or be creative in how you want to say combine two different sets or tables. But yeah, so that's it. Thank you so much for watching and being a subscriber. And if you aren't here, that's okay. We hope eventually, as you're watching more of the videos, you can definitely end up clicking on that subscribe button. But yeah, make sure you are keeping up to date. I'm definitely going to have more SQL videos that cover more complex topics or examples of things that you might kind of get stuck on at work and try to Google, like, oh, how do I do this? And I'm hoping to be able to make videos that exactly attack some of those issues and kind of show you how to resolve those issues. See you next time. Bye.